Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for almost a decade, and I've achieved a 99th percentile score on the GMAT and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS think our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go. Welcome to Real GMAT Problems, episode 12. Doing real GMAT problems is one of the fastest ways to improve your score. So let's go through some more examples together and help you get to the next level. We're going to walk through 3 examples of actual past GMAT questions together today. The problems that we're going to be doing are from the 11th edition of the official guide for GMAT review, and you can web search them if you'd like to follow along visually, but I know many of you will not be in that situation, and that's okay. Just so you know, the 11th edition of the official guide for GMAT review is out of print, and that's partly why I'm going through questions from that book, because that way, if you practice with the questions from this year's official guide, the current version of the official guide, there shouldn't be any overlap between the questions we're going to work through here and that book. The official guide, or what you'll often referred to as the OG, contains retired problems that have appeared on actual past GMAT exams. So it's super helpful because someone somewhere saw that question on a real test, and those questions are the best way to simulate what test A is going to feel like. So again, I definitely recommend engaging with questions from that book and also engaging with the questions that I'll go through here. And when you do the new questions, hopefully you'll be able to take what I'm going to teach you here and get even more comfortable executing well on it. All of these questions are also on Khan Academy if you want a different perspective on how to solve them. I'll give you a chance to work through each solution on your own if you want, and then I'll discuss my thoughts on the problem and my recommendations for what you want to learn from each one. And what I recommend doing is pausing after I read through each problem, and at the very least thinking about how you would solve it. You might not be able to execute all the steps in your head if you're on the go, but just see how far you can get with a mental solution and try to visualize what you would actually write down. It's a really good workout. Now, if you're on the go and you have access to pen and paper, like you're on a train or something like that, that's ideal. Try to make some progress on the problem before we review and focus on writing good scratch work. You want what you write down to be clear enough that someone else can tell how you thought through the problem just by looking at what you wrote. If writing isn't practical right now because you're driving or something like that, that's fine. Just do your best to visualize what you would write down. Like I just said, for most of us, that's going to be way more productive than just trying to do all the computations mentally. So here we go. This is problem number 39. The problem says, if x equals -3, what is the value of -3 times x to the second power? Option A, -27. Option B, -18. Option C, +18. Option D, +27, and option E, 81. Let me read the problem again. The problem says, if x equals -3, what is the value of -3 times x to the second power? So again, pause if you'd like to work through this. I recommend that. On the surface, this problem might seem quite straightforward, and if you've taken the time to practice and understand PEMDAS well, it should be. But 7% of people pick E, which is not the right answer, and that's way too many. So let's dig into what might be causing people to have problems here and make sure that you're set up to avoid missing a question like this. First things first, if you're not familiar with how PEMDAS or exponents work, this problem is going to be super tough. So I highly recommend brushing up on those topics before proceeding. If needed, we've got episodes on each topic linked for you below. Assuming you're familiar with the basics of those topics, one small but super valuable tip that I can give you is when you're plugging in a value into a variable in an equation, like we are doing here, which is plugging in -3 for x, because the problem literally tells us x is equal to -3 and then uses x in the question. So we're going to plug in -3 for x. What I recommend when that happens is you always write parentheses around what you're plugging in. Okay, I'm just going to repeat that because I think it's like a small tip, but it has tons of upside and very little downside. I'm recommending that anytime you're inserting something for a variable in an expression or an equation, write parentheses around what you're plugging in. So here, I would write the question as -3 times in parentheses, -3, which I'm plugging in for x, close parentheses, to the second power. If it was a more complicated equation and it said x is equal to y plus z, then when I plug in y plus z for x, I would put parentheses around y plus z when I'm plugging in. It's just a good habit. It's very difficult to go astray with it, and it's way too easy to go astray without it. So it's a small tip, but I think you'll be really happy that we discussed it, and I think you'll be super happy if you implement it. So in this particular case, the proper way to execute this recommendation I'm giving would be, again, writing -3 times in parentheses, -3, we're replacing the x with -3. Problem told us x is equal to -3. Close the parentheses and then take that to the second power. So that's going to set you up for success and avoid some of the major pitfalls. Next, what you want to do is remember that exponents come before multiplication in PEMDAS. So before multiplying by -3 on the left, we want to make sure we square the -3 on the right first. This is why you're going to want your parentheses around -3. It's easy to write it as -3 times -3 to the second power with no parentheses. But what that means, if you're following PEMDAS strictly, is that you're going to square 3, +3 first, and then multiply it by -1. And we don't want to do that. We want to do -3. We want to do it the other way, because if we did it this way, then we're going to get -3 times -3, and that's going to give us a problem. But let me just back up there, because that actually, the way that I just described that is kind of confusing. So it's easy to miswrite the problem as -3 times -3 to the second power with no parentheses anywhere. And what you would do if you're following PEMDAS strictly is you would do +3 to the second power, because the e for exponent comes before the m for multiplication in PEMDAS. And then you have that negative sign floating right in front of the 3 to the second power. So that then becomes -9. And you would have -3 times -9, which is going to lead you to the wrong answer, +27. We'll revisit that in a second. Instead, what we want to do is we want to do -3 times in parentheses, -3, close the parentheses, to the second power. And that means the first thing we do when we go to do the exponent is we do -3 times -3 when we square that. And that gives us +9. And then we multiply that by -3, and that gets us -27, which is the correct answer. So you might be able to just feel the potential pitfalls there. And it's like this stuff is pretty narrow, pretty detailed, but that's the difference between getting this question right versus wrong. And I think it's such an actionable thing that I think it's just crazy to not adopt that habit personally. So once we've squared -3 to make +9, we multiply that by the -3 to the left, and that gets us -27, which again is the correct option. Now, notice that +27 is an option. So if you forgot the parentheses and you made that mistake, again, that's the difference between getting the problem right versus wrong. And once you've taken the time to understand PEMDAS and the basics of exponents, that's the last kind of question you want to be getting wrong on the exam. So it's worth noting that the score algorithm on the official test does take the difficulty level of the question you're looking at into account when computing your score. So missing low difficulty questions like this one would definitely hurt your score more than missing hard questions. This is part of the reason I'm going through some of these questions with you. For sure, if you're just getting back up to speed with math, or you never felt you were good at math, it's great to start with these lower difficulty level problems. But even if you're more advanced and you've been studying for a while, I think it's really, really wise to revisit these basics, because I think a lot of times we just need to be reminded of the habits that are going to take us where we want to go, even if we know the material super well. That was definitely the case for me. I'll just say that. So if you want more information about how the scoring algorithm works, I highly recommend the free video on our website at thegmatstrategy.com. It's usually better to explain the scoring system via video rather than audio. But I do briefly touch on it in an audio description. If you're on the go right now and you want a quick primer on the scoring algorithm, that's in the last 10 minutes of our episode titled How the GMAT Works in 2025, which we'll link for you below. But it is at the very end of the episode. So just FYI, if you want to cut straight to that, it's in the last 10 minutes there. So option D here, positive 27, clear potential pitfall. And you can see that the exam is directly testing your ability not to make that mistake. Something to consider. So the fact that 7% of people pick E is also pretty interesting because that's 81. And I want to dig into that for a second. So imagine setting up the incorrect one that we've talked about a couple times now, -3 times -3 to the second power with no parentheses. It's tempting to think that you just execute the math from left to right. And if you did that, you would get 81 because you would do -3 times -3, which is +9, and then you would square that result and you would get 81. So think about 7% of people are doing the problem that way. That means they have a serious PEMDAS issue, like they're not doing the exponent first. So as crazy as this might sound, we did do a whole episode on PEMDAS. So please make sure you're perfectly clear on how to use PEMDAS and your exponent rules. If you are, this is the kind of question that can be a total breeze. If you're not, then this is the kind of low difficulty level questions that's super easy to miss and can really drag your score down. Obviously, we don't want that to happen. That is not why we're making this episode right now. We're making this episode to bump your score up. Also, it is worth noting that good execution habits are super, super valuable. So I just want to reiterate my tip of always writing parentheses around numbers or expressions that you plug in for variables. Again, it seems so small and detailed, like it couldn't possibly be the difference between you seeing your goal score and not, but often those kinds of habits are the difference between being right and being wrong, and this problem is a good example of that. So it looks about 10% of us total could really benefit from that advice. People who pick D plus people who pick E combined, both of which are incorrect. So let's expand on some of these concepts with another couple problems. I think this stretch of 3 problems is a great time to really focus on these basics. This is problem 40. By the way, if you have questions about anything that I'm talking through here, you can DM us anytime at the GMAT strategy on current social channels, or you can email us. Our public email address is contact, CONTACT, at thegmatstrategy.com. Problem 40. In parentheses, as the numerator of a fraction, you've got 29 squared plus 29. And the denominator of that fraction is the number 29 by itself. Let me just reread that. So as the numerator of a fraction, in parentheses, we've got 29 squared plus 29. And then the denominator of that fraction is the number 29 by itself. Option A, 870. Option B, 841. Option C, 5858. Option D, 3131. Option E, 3030. Another one here to make sure you're strong with your basic math, fraction, and exponent skills. And I just think the way that this problem is set up is really telling, where it's like all these 29s floating around, and it's almost like this misdirection thing where the test is just trying to throw you off. Again, just really trying to hammer, like, how well do you know the basics? Not just do you know the basics, but have you like practiced and rehearsed to the extent that you can execute well? So there's actually a couple different ways to approach this problem, even though it might seem really simple. And related to the previous question, 4% of people are picking C, which is not the right answer. So let's discuss why that might be happening and help you elevate your skills if that answer was appealing for you for whatever reason. So let's start with the first approach, which I like a lot, which is actually splitting it into 2 different fractions rather than dealing with it as a singular fraction. This is an opportunity that the GMAT actually presents pretty often. So it's kind of an interesting thing to dig into. Let's start here. If you saw x over 29 plus y over 29 in a problem, you might think, oh, there's a common denominator. Let me just add these fractions to get x plus y over 29, which is completely correct. and something we've talked about a lot in that GMAT Basics series. But it might be super unnatural for you to see something like x plus y over 29 and think, let me just separate that into x over 29 plus y over 29. Even though that's a completely correct mathematical move, that would be super, super unusual in like a school math course. It would be very unlikely that you would like unsimplify something. So most of us are it's just not even really thinking about that. And that's why I wanted to go over this question with you, because it's a helpful thing to think about in this problem. So that's why the GMAT often presents this kind of situation, I think. I don't know exactly why they do it, but just speculating. I think it tests your ability to think a little bit differently, like kind of think outside the box a bit, and or like truly have mastered a detailed subject like fractions. And mastering detailed subjects and thinking outside the box, we could theoretically make the argument that both of those are valuable skills in business. So if we give the test writers the benefit of the doubt, they're using this arithmetic situation to test some interesting executive skills. If we don't give them the benefit of the doubt, then maybe it's just a tricky problem. So if we apply the same concept that I was just talking about of separating x over 29 and y over 29, if we take that concept of taking like x plus y over 29 and separating it out into two fractions and we apply it to this problem, then we can separate those two fractions and turn one fraction into 29 squared divided by 29 plus a second fraction, which is just 29 over 29, which for most people is going to be a lot easier to manipulate and solve than how the question is originally presented as a singular fraction. So let's go ahead and solve that. If we do 29 squared divided by 29, that's just 29 by itself, because we can cancel the 29 in the numerator and the denominator to get 29 over 1. If you want help understanding how to cancel well in fractions problems, we've got an episode to help you out with that linked below as well. For the second fraction, 29 divided by 29 is just 1. So we would wind up with 29 plus 1. And that gets us to our correct answer of 30, 30. Again, super useful technique to get used to using, and a good representation of the kind of thinking that the GMAT often rewards. Again, it's part of the reason I'm taking you through some of these official GMAT questions, because as you can see in that problem, like it's debatable whether understanding fractions well is enough to get that question right seamlessly. I think having some experience and having seen that move done of separating the fractions a couple times it's like helpful by itself, almost like a pattern recognition kind of thing. So hopefully that's going to translate really well as a result of our discussion here. Let's explore a different way. So if you've got some experience with exponents, you may have also thought about factoring out a common term in the numerator, and this is also a great move in my opinion. So let's walk through how this might look. Think about just isolating the numerator for a moment and just ignoring the denominator. What number could divide 29 squared and also 29? Because in the numerator, we've got 29 squared plus 29. What number could divide both those numbers? Hopefully, you're thinking 29 itself. So we can factor that out to create 29 times, in parentheses, 29 plus 1. If you're not comfortable with factoring yet, or it's just been a long time since you've done some factoring, we've got an episode on how to get better at that linked below as well. Now, if we made that move and factored, and we created 29 times, in parentheses, 29 plus 1, and in our denominator we put back the 29, then you might see we've got some good news, because now we've got multiplication, 29 times 30 in the numerator, and then just 29 on the bottom, which means we can just cancel the 29 in the numerator with the 29 in the denominator, and we would wind up with our answer, which is 29 plus 1, or 30. So also a really good move. I like that move. It's probably worth being comfortable with both approaches we just talked through, because they both shine in different situations. Having said that, it's completely fine if you favor one over the other and always default to that one that you favor. Having said that, I think you should at least be familiar with the other approach. That's pretty much the long and short of those two approaches. Let's briefly touch on why so many people might be choosing C, which is 58. To me, it looks like people are probably canceling the denominator with just the left term in the numerator. I'm just guessing here, but that seems reasonable. Over the many years that I've been helping people out with this exam, I've seen those kinds of things happen a lot. So they see 29 in the denominator and they want to cancel it out. And so they just cancel it with the 29 squared, but they don't cancel it with the other 29 in the numerator by making two fractions like we did in the first approach, or by factoring like we did in the second approach. So they'll wind up with 29 plus 29, which yields 58. So this is an issue with understanding how canceling works. You can cancel one item when multiplying. We actually did that with the factoring approach, but you cannot generally cancel just one thing with addition. With addition, you'll usually need to cancel with both terms. That's why factoring works so well. And also why when we split up the fractions into two fractions with our first approach, we got the right answer. I can't just cancel in one of the terms in the addition without creating a, what's the right way to say that? Creating something that is not mathematically accurate. It doesn't actually net out to be the right value. So if you made that move incorrectly, that's fine. You'll just want to improve your understanding as soon as possible. The fractions math basics episode should help a ton with that. This is part of the reason I think it's worth talking through these kinds of problems, even briefly, because it's just so tempting to do something like that, even if it's not correct under time pressure. And this is also the reason we created that GMAT Math Basics series that I'm going to reference a lot in the first place, because those basic skills are just foundational. Again, they might not be enough. That's why we're also going through this series with you, but man, it really pays to know those basics well. So please take advantage of that if you find yourself making those kinds of mistakes. If you're already rock solid on your math basics, then that's great news. Again, if you have questions here, just reach out anytime at the GMAT Strategy on current social channels, or contact at thegmatstrategy.com if you prefer to email. Let's do one more. I think this question also really touches on a lot of these same concepts. Kind of interesting. Slightly different angle on them, though. This is problem 41. The question reads, if x equals 1 minus 3 times t, and y equals 2 times t minus 1, then for what value of t does x equal y? Let me read that again. If x equals 1 minus 3t, and y equals 2t minus 1, then for what value of t does x equal y? Option A is 5 over 2. Option B is 3 over 2. Option C is 2 over 3. Option D is 2 over 5. And option E is 0. Again, recommend pausing, mentally visualizing your scratch work, or doing actual physical scratch work. Highly recommend not doing the math in your head on these questions. I think it's just way too risky, based on what I've seen. It's a great lower difficulty level problem to practice some algebra skills, including solving a system of equations with a few variables. If you're not sure how to use substitution, or it's just been a while since you solved a system of equations, please check out our Math Basics episode on that topic, which is also linked below. Great example in this question of how the exam doesn't always ask us questions in ways that are kind or easy to understand. So you may struggle with figuring out what a question like this is actually asking, and that's completely fine and totally natural. Most of us started by struggling, and then we just stuck with it and improved over time. What's worth understanding here, though, is that we want x to equal y, and we're looking for a value of t that can make that happen. This is definitely a situation tailor-made for algebra. This is like what algebra exists to figure out. So what we would want to do is set x equal to y, and then substitute the expressions that are equivalent to x and equivalent to y that contain t. Those are the expressions we were given at the beginning of the problem. So again, just in case you were a little thrown off by the way the question is asked, the question's asking which value of t would make x and y equal to each other. In order to find that, we're going to set x and y equal to each other, then solve for the value of t that makes that equation true. Again, that is what the tools of algebra are made for in the first place, is showing you the value of unknowns that would make a particular relationship work out. That's what an equation is. It's a relationship, and unknowns are variables that we don't know the value of. Algebra helps us figure those out. We don't know the value of t yet. That's what we're going to find out. So we know that x is equal to 1 minus 3t. So let's replace x on the left side of our x equals y equation that we created with 1 minus 3t. So that would give us 1 minus 3t is equal to y. Then on the right side of the equation, let's substitute for y. We know y is equal to 2t minus 1. So let's replace y on the right-hand side of the equation with 2t minus 1. That's going to give us the equation 1 minus 3t is equal to 2t minus 1. Now, if we solve for t, we should get the value of t that makes x equal to y. So let's do that. If you're not sure how to simplify equations or isolate variables, we've got a lesson on that linked below as well. All I'm going to do here is use the golden rule of algebra and add 3t to both sides of the equation. That would give us 1 equals 5t minus 1. If you don't remember the golden rule of algebra, it's treat one side of the equation the way you would treat the other side of the equation. Basically, treat both sides of the equation equally. It's similar to the golden rule in life. Treat people the way you want to be treated. So we got 1 equals 5t minus 1. Let's add 1 to both sides so we can start to isolate t here. That's going to give us 2 equals 5 times t. Then all we have to do is divide both sides by 5 to get 2 over 5 is equal to t, and that's our correct answer, which is option D, as in delta. Now, notice option A here. About 3% of people end up selecting that. In fact, if you look at the video on Khan Academy of Cell solving this problem, he actually makes that exact mistake and writes 2 over 5, and then they have to edit it out later. Now, just to be clear, we all make mistakes, and if I did a ton of GMAT questions back-to-back live with no edits on YouTube like he did, I would probably make way more mistakes than Cell does. The point is that even people who are incredible at math are prone to these kinds of mistakes. And you can see the exam is directly testing your ability to spot those mistakes and avoid them. We saw this with earlier problems today. So you can think about different executive skills that this might be measuring: attention to detail, ability to prepare in advance, remaining cool under pressure, or at least being able to execute well under pressure, being able to execute complex processes in general consistently and reliably. Again, I'm reading into the exam. I have never seen a published piece of material that says GMAC has that intention when they make the GMAT, but I think it's a good framework to use. And then that way you're practicing your executive skill set, not just studying for a test that might appear meaningless on the surface. So getting back to business here, my best advice for not falling into those traps: always write each algebra operation under both sides of the equation when you're doing algebra. I'm just going to repeat that. Always write each algebra operation under both sides of the equation when you're doing algebra. If you could see my scratch work for this question, you would see that each side of the equation has divided by 5 and divided by 5 underneath it before I write the final solution. And that just makes it way less likely that I'm going to invert the fraction by accident. And that's a habit that I built by personally missing way too many questions like this one. So, again, it's like sometimes you might have to get to the point where like the pain of missing those types of questions is bigger than the pain of changing your behavior. Hopefully that's not you. That was unfortunately me. I was a little hard-headed, a little stubborn, maybe a lot, if I'm being honest. So I'm doing my best here to set you up for success with good habits from the beginning, because I wish someone had done that for me. I think it would have saved me like months of my life that I'm probably not getting back at this point. So hopefully you can benefit from it. At least we can save you some months. So just to drive this point home, the more you condition yourself to do this properly in practice, the easier it's going to be to do it properly under time pressure. So final note I think that's worth making is on questions like this where over 90% of people are getting it right, and as a result, it's categorized with a low difficulty rating, it's still way too easy to get the problem wrong. So yes, you should absolutely know the math involved. That's critical, and that's why we made the Math Basics series, like I've said a couple times. Hopefully that's super valuable for you to see how those basics play out, though, in real GMAT questions like this one. But it's also worth noting that simply being great at math may not be enough for you to reach your goal quant score, and that it's worth examining your habits and asking yourself if you're setting yourself up for success with how you're executing your math in practice, not just your math knowledge and measuring your skills and projecting your score just based on knowledge. Obviously, knowledge really matters, but execution matters arguably just as much or more. So I hope that helps you out. Again, just giving you the advice I wish I had gotten when I was in your position, and hopefully practicing the golden rule to the best of my own abilities. If you want help improving your execution skills, we're going to link our episodes on discipline and on consistency below. which should really help you out if you struggle with these kinds of mistakes or you just struggle with your discipline and consistency in general. Those are two things I struggled with just way too much as a young person. And man, I wish I could go back in time and redo some things. But next best thing is just be better today. So I'm gonna try to get as close as I can to time travel by helping you out early on in your process. So if you have questions, again, feel free to reach out to us anytime at the GMAT Strategy on current social channels or via email contact@thegmatstrategy.com. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the exam, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score in half the normal time. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies. Talk to you all soon.